Okay, so I think we can start now. So good afternoon, everybody. So last time I explained the concept of interrupt, what interrupt means, how it is useful, and then after that I explain what should you do to program interrupts. You should understand, as shown here in this table, we have several sources of interrupts. We have several sources of interrupts as shown here in the table. Okay. The good thing is the way you can program one interrupt almost the same. Okay, so it's almost the same, just different register, but everything you have to do for one interrupt, almost the same thing you have to do in other interrupts. Okay, so we have different sources of interrupts as you see here. Today I'm gonna start teaching in details IRQ, and hopefully I can also teach RTI as well. Okay, so and this was the conclusion. You should understand very well, guys. If you wanna program any interrupt, what you have to do in the main program, number one, you have to initialize the interrupt vector. As I said last time, what this means, it means you have to tell the microcontroller where is your subroutine. You can put your subroutine anywhere in the memory, but you have to tell me where it is. And the way you have to do it, you have to do this way. You have to say org, and then you have to use a specific number for each interrupt. So as shown here. So for RTI, you have to use this number. For IRQ, you have to use this number. So what happens here, as I told you guys, there is we reserve two locations for each interrupt to store the starting address for the interrupt subroutine here. So that's why you can see this one is incremented by 2. Okay, so everyone here is incremented by 2. So in this location and next location, in these two locations, this one and next one, you have to you can put the interrupt subroutine for IRQ. You can put it anywhere in the memory, but the beginning address you have to put here in this location. Okay, these are fixed location. How can you do that? The way you are going to do it, as shown here, we are going to say org and then this location. That's what I'm telling you guys. The way you program one interrupt will be the same. The only difference is you have to do this one for any interrupt source. The only difference is you are going to change this number. That's it. And for sure, the name of the subroutine. So when I change this number, for example, here, in case of RTI, instead of putting this number, I'm going to put this number. That's it. And this is the name of the subroutine. Okay. And what this one is doing, actually, as I said before, when you put the name of the subroutine, this name is replaced by the beginning address, right? So I'm going to store the beginning address starting from this location. Okay. So this is the first thing you have to do. Also, you have to enable global interrupt, CLI. Also, you have to enable local interrupt. I told you for every interrupt source, there is 1 bit to enable this source, local bit, right? So also you have to do some kind of configuration. And this configuration actually is different from one source to another. So in case of IRQ, the configuration is, do you want to trigger interrupt when the pin has a falling edge or low level? Okay. In case of a timer, or RTI is a timer. In case of RTI, so actually the configuration here, you have to set the time. Do you need interrupts every 1 millisecond or 2 milliseconds and so on? Inside the interrupt subroutine, you have to put RTI at the end. At the end, you have to put RTI. Also, you have to write a comment to clear the interrupt flag bit. Okay. Again, that's what I'm telling you. For any interrupt source, you have to enable the local bit, right? The only difference is this local bit is going to be in different registers. So for this interrupt source, I'm going to tell you this bit is in this register. For the other interrupt source, this bit is in a different register, and so on. But for all of them, for any interrupt source, you have to do this one. Also, for any interrupt source, also you have to clear the interrupt flag bit. But again, the only difference is that this interrupt flag bit is going to be in different registers. That's why every time I teach an interrupt source, I have to tell you where is this interrupt flag bit in which register. Okay. So anyway, let's start with the first one here, IRQ. Okay. So number one, what is IRQ? What is this? Okay, very simple. IRQ, as I told you last time, guys, is this pin. This pin. It's an external pin. This is the microcontroller. There is an external pin this way. Every time there is a falling edge on this pin, you are going to trigger interrupt. This is the meaning of IRQ. So IRQ, I want to trigger interrupt every time there is a falling edge. Again, this falling edge can come from a sensor, it can come from a device, from wherever, okay? So number one, tell me, where is this bit? The bit is here. Okay, this bit here. PE1, this is IRQ, okay? Number two, tell me how I can program it, okay? Similar, this is the summary here. So now I'm gonna give you details. How can you do this one? How can you do this one? How can you do this one? And so on, details. So let's start with the first one here. First of all, what you have to do, you have to initialize the interrupt vector. And for IRQ, you have to use this number, FF2. This is a fixed number. It's already in the table. Is that okay? Number two, now you are going to make a subroutine in your program. You are going to make a subroutine. You can call it whatever you want to call it. For example, here I decided to call it IRQ underscore ISR. And you can call it whatever you want, but you have to make sure whatever the name you have here, you have to use the same name here, so that the code warrior is gonna replace this name with the beginning address. For example, 7,000 or 4,005, whatever. Okay. So anyway, so that's what you have to do in your program. So now your program, different from what we did before. Your program is not going to have two orgs as we did before. Now your program can have more than two. So you have one org, 1,000, and then you have to put data here. You have org 4,000, and you have to put your code here. Okay. Then you can have multiple orgs here. So for every interrupt source, you can have multiple orgs. For every interrupt source, you are going to have one like this one. For every source, you are going to have one like this one. In the very beginning, you can put equate. So if you have any equate, it has to be in the very beginning. This is the structure of your program we're going to do. Okay. Now, also, I have to tell you where is the enable bit, local enable bit. Okay. Also, I have to tell you what kind of configuration we have here. The configuration we have here, guys, do you want to trigger interrupt when the pin has a falling edge, or when it is low level? What you want to do? It's up to you. This is something you can configure, right? So how many choices you have here? I have two choices. How many bits do you need for the two choices? I need only one bit. You get what I'm saying? So all what I need in a register, I need one bit. This bit, one value for falling, one value for low level. That's it. Is that okay? Also, I need one bit for the enable bit. Okay? And here, by accident, the configuration, the bit I need for configuration and the bit I need for the enable, both of them are in the same register, just by accident, okay? And this register is called interrupt control register. Interrupt control register, INTCR. This is the name of the register, interrupt CTR, okay? So in this register, guys, as you see here, we have two bits here in this register. This bit, this is the enable bit, this one here, the enable bit. If you put one here, so you enable interrupts for IRQ interrupts. If you put 0, you disable IRQ interrupts. Is that okay? So at any time, if you want to disable IRQ interrupts, all what you have to do is just put 0 here. You disable IRQ interrupts. If you want to enable IRQ interrupts, just put 1 here. Is that okay? So one bit to enable, or this is the enable bit. Also for configuration, we have bit number 7 here. So in this bit, guys, if I put here 1, so actually here you want to trigger interrupt for falling edges. If you put 0, you want to trigger interrupt when the pin has low level, has 0. Is that okay, guys? Very simple, right? So in the main program, you have to write only one command in the main program here, guys. Look, here's a command I have to write For example, for sure I have to enable interrupt, so I have to put one here. That's for sure. Also, now if you want to select a falling edge, so you have to put also one here. If you want to select a falling edge, this is gonna be, so all what you have to do, guys, I have to say move byte C0, because 11000 this should be C0. Okay, so you can move C0 to here. Is that okay? That's it. You have to put, this is a configuration. This is similar when you configure ports, input ports or output ports. We put it in the main program. It's the same idea. Right? Also, however, if you want to program it for low level, all what you have to do, you just put 0 here. Now the number is going to be 40. That's it. So all what you have to do here, guys, if you want to, you have to put C0 if you want to trigger interrupts for falling edge, or you have to put 40 if you want to trigger interrupts for low level. Is that okay, guys? Just you have to write this statement here. At any time, if you want to disable interrupt, just put here 0. 1 for enable, 0 for disable. Okay. I want to tell you something, because I'm going to teach more registers right now, guys. I'm going to teach more register. I don't want to be confused. These registers are different from the register I taught before, like register X, register A. They are different. These registers are similar to port A, data direction register, and so on. So the register I'm going to teach right now, guys, these registers are I call them registers. However, the way I'm going to program them, like memory location, they have addresses, okay? And every instruction I used before for memory location, I can use it with these registers. And the address, actually, the address of this register is this address, and you don't need to use numbers, because this address is already it's already defined in the include files, the file you include in your program using equate, because we don't want to use numbers. I just want to use English names. So the conclusion is this register and any other register I'm going to teach in the future. Okay, we call them register, but the way I'm going to use them like memory locations. Okay, and if any instruction used to put before for memory location, I can use with this register. Okay, guys. So what else I have to write in the main program? For sure, you have to write CLI. Once you write this CLI, and once you write this one, now interrupt is working. Why? Because this one is going to enable the global interrupts. This one is going to enable the local. Once you enable the local and the global, now IRQ can work. Once a falling edge come, so you are going to trigger interrupt right away. Okay. Number 2, what should I write? So again, I'm gonna come to this slide. For any interrupt source I'm gonna teach, I'm gonna come this slide, because that's what you have to do in the main program for any interrupt source. That's what you have to do in the interrupt subroutine for any interrupt source. That's why I'm gonna always come here. Okay. So what else do we have here? Yeah, for inside the interrupt subroutine, I told you there is an interrupt flag bit, and you have to use instruction to clear it. I told you that's very serious. It's very serious. If you forget this instruction, your program is going to be frozen. It's going to be frozen because you are going to have infinite number of interrupts, right? So you should not do that. Also, you have to end it with the instruction Rti. You remember the subroutines we used RTS, return subroutines. This is for normal subroutines, but for the interrupt subroutines, we are going to end it with Rti. Okay, so tell me, you are telling me, as I explained before, guys, we have one for every interrupt source. We have one bit we call interrupt flag bit, right? So when the device want to trigger interrupt, it's gonna put one here. That's okay. And once I serve the interrupt, inside the interrupt subroutine, I have to write a command to clear this one. Is that okay? That's what we agreed on. Okay. However, always we are going to do that, always. However, the only exception here is IRQ, because this one is automatically cleared in case of IRQ. Is that okay? So you don't need to worry about this one in case of IRQ. But all the other interrupts, you have to write instruction. The only exception is only IRQ. You don't need to do anything. This is done automatically. Okay. Any other interrupt source, you have to write a command to clear the interrupt flag. Yes. Return interrupt subroutine, RTI. RTI return, maybe return interrupt subroutine. Okay, now I want to give you a program to see you how can you use this one in a program. So what I want to do here in this program, guys, is I'm gonna use these are the LEDs. These are the LEDs. In the very beginning, I'm gonna turn one LED on. Every time there is an IRQ interrupt, so I'm gonna shift this one. So this one is on. Once you trigger IRQ interrupt, I'm gonna shift this way. Another IRQ interrupt, I'm gonna shift this way, and so on. Okay, guys. So what I want to do right now, guys, is every time there is an IRQ interrupt, one LED is on, so I'm gonna shift. I'm gonna shift. This is what I'm gonna write inside the interrupt subroutine. Okay. Every time there is interrupt, shift the LED. That's it, right? So it's just a very simple program in order to teach you how can you use IRQ. Okay. So what I'm gonna do now, as you see here, guys, in the main program, for sure, in the main program, I have to do configuration. I have to a bunch of configuration. I have to do configuration for ports as we did before. This port input, this port is output. I have to enable LEDs. I have to disable 7 segments, similar to what we did before. On top of that, I have also to do configuration for the IRQ interrupt as well, right? That's it. That's all what I mean in the main program. However, my task, the task I have, I'm gonna write in the interrupt subroutine. Okay, so every time there is a falling edge on the pin, we are gonna call the subroutine. The subroutine is gonna shift port B, shift it. Okay, and once you shift it all the way, so here this LED is on. So when there is an interrupt, so this one is on, this one is on. If you shift all the way, and now it's all of them are dark, so I have to come back to here. Okay, so once I shift all the way, I'm gonna come back to it. How can you do that? Once I find that port B is equal to 0, that means, so I'm gonna put 1 here. Okay, in port B, every time I'm gonna shift is a 1. Every time I'm gonna shift is a 1. Once it is 0, 0, 0, when this one went out, okay, so I have to bring it back to here. So that after you turn this pin on, I have to bring it back to here. Okay, guys. So tell us how can we do it? Okay. So number 1, this is the main program. So in the main program, guys, I'm not going to teach you this part because this part is similar to what we did before. So here you have to configure port B as output. You have to port J, port P, and so on. Also here, I'm gonna write 1 here on port B in order to turn one LED on, right? And then this is just normal for ports. This part here in order to configure IRQ, guys, I have to do this one here. I have to do this one. Also, I have to do this one. That's it in the main program. That's it. Very easy, very, very easy. All what you have to do here. The good thing, you guys, all the time you are gonna. That's a good. The good thing is that programming interrupts is very easy because every time I'm gonna use the same code. So here always I'm gonna use this one. The only thing you may need to change is this one. Instead of C0, I'm gonna make it 40. If you wanna respond to 0, okay, that's it. But everything will be the same. So once I do that, guys, this is the main program as I told you, because now, as I told you, my program should have a main program and also should have interrupt subroutines here. So this is the interrupt subroutine. This is the name of the subroutine. It has to be, as I told you before, it has to be the same name I'm using here, right? So what's going to happen here, guys, once I come here, because this is a very simple program, there is no task. I'm not running any task in the main program. So that's why I'm going to keep looping here. So I'm going to just keep looping here so that every time there is IRQ, I'm going to go serve the interrupt and come back. Go serve the interrupt and come back. Is that okay? Again, this is just a very simple program. However, in reality, maybe you are going to also write a task here. Again, okay, you understand what I'm saying? It's just a very simple program. I want to teach how can you program IRQ. That's why you want only one test, and this test I do it in IRQ. Okay. However, you can put another test here if you want. And then here in the interrupt subroutine, guys, Forget this part now. I'm going to talk about it in a minute. Forget it for now. So here, as I told you, that's what you should understand. That's what you should understand. What interrupt means? It means every time there is a falling edge, you are going to execute this code. Every time there is a falling edge, you are going to execute this code. Is that okay? So now it's up to you. What do you want to do? Every time there is a falling edge on the pin, what do you want to do? It depends on the application. And in this application right now, I want to shift the LED. I want to shift the LED. How I do it? I'm going to do it this way. So what I'm going to do, as you see here, number one, shift left. I think I made a mistake. This one, shift left. I think when I explained, I moved to this way. It's not a big deal. But here, this program, I'm going to shift it to the left. So I'm going to put one here. This one is on. So every time here, I'm going to shift left. And then I'm going to check. If it is not 0, go to end. If it is not 0, if port B is not 0. Again, someone can ask me why there is no compare here. Simply because you don't need compare. Why you don't need compare? Simply because if after you shift, if the result is 0, this function, this instruction is going to set the 0 flag. That's it. Anyway, so if not equal, come here. Now, if it is 0, if port B is 0, if port B is 0, that means I shifted, the one was here. I shifted all the way, it was here, and then I shifted out, right? So in this case, I have to return back to the beginning again, so that after you turn this one on and you shift it, this one should be on. How I made it, as you see here. So as you see here, guys, if port B, here, port B does not equal 0. If it is equal to 0, it's going to come to here. If it is equal to 0, so I'm going to put 1 here. Okay, guys? So now, very simple, you should understand. I have a subroutine. Every time there is a falling edge, you are going to execute this subroutine. Okay? And then write whatever you want to write here. Okay? You can simply you can change this program to do something completely different. For example, okay, here I want to do something else. So here, all what I'm going to do, I'm going to replace this code with another code. For example, okay, what I want to do here, I want to toggle one LED. For example, so every time there is a falling edge, if one LED is on, I'm going to make it off. If it is, by the way, this falling edge, as I'm going to explain right now, is coming from a push button. So in reality, it can come from anywhere. But here in this example, this one, okay, let me show you. Okay. Okay, so I just want to show what I did here, guys. Okay, look here, guys. I told you here on the board we have here 4 push buttons. Here we have 4 push buttons. I did not explain yet how can you program them. Okay, so what you should understand, these 4 buttons are connected to PH0, PH1, PH2, PH3. Similar to these 4 switches. Yes. So here they are connected to the same pins. Anyway, I'm going to explain it in details, but the idea is that every time you push the button, if you have like PH0, every time you push the button, you are going to make a pulse, something like that. Because when you push the button, you are going to connect the pin to 0. Once I release, it's going to go up. So here you press, here you release. You understand what I'm saying? So every time I use one push button here, guys, when I press the button, you are going to generate a pulse like this one here, okay? Because you are going to connect the pin to 0, and then once you release, it goes up again. So what I did in order to trigger interrupts in a nice way, in order to trigger IRQ interrupts in a nice way, what I did is, and that's what we're going to do in the coming lab anyway, this one here, can you see this one? Yeah, it's the second one here. This is IRQ. I connected external wire from here to here. Sorry, this one.
from the second one here, this is this one, because this one is the second one, I connected external wire here. External wire. Why I connected external wire? Because as I told you, and I'm going to explain in details, every time I press this button, BH0, I'm going to generate a signal like this one. So if I connect a wire between BH0 to IRQ, so every time you generate a signal like this one, you are going to transfer the signal to IRQ to trigger interrupt. You understand what I'm saying? Just a nice way, okay? So that means every time I press the button, I'm going to trigger one interrupt, okay? I'm going to give you more details. Just give me 1 second. Okay. So what I was explaining here before I choose a video, because before I explain more things. Okay, what I explaining here, guys, something very simple. All what you have to do, guys, here, this is the body, this is the body of the interrupt, right? So if you want to do something else, just remove this one and put this one. For example, if I do something like that, what's going to happen? For example, look here, guys. What's going to happen here? You are going to XOR, you are going to flip one LED. What it means? It means every time I press the button, I'm going to trigger IRQ interrupt. When you trigger IRQ interrupt, you are going to flip one LED. It's on, make it off. You got what I'm saying? That means using a push button, I can turn one LED on and off. Okay. You can do something else, and it is very interesting, very important, very interesting. I can count the number of events. As you see here, look here, I can say something like that. So every time there is one interrupt, increment count and move count to port B, for example. Count here is a memory location. If I want to count how many events or how many interrupts I receive, I can do something like that. You got what I'm saying? So what do you mean? What are you counting here? I'm going to tell you what I'm counting here. Look here, guys. For example, I have here, sometimes we have something like infrared light. If you have here like transmitter and receiver, okay? And this is infrared light. So you cannot see this light. Every time someone, for example, enter a store, you are gonna cut this light. Every time you cut the line, you are gonna trigger a falling edge here. So this is, it happens a lot in many applications. I want to count how many events happen. I want to count how many events happen. Is that okay? Or I want to count how many people enter the store. So I can put infrared this way. Every time you cut the line, this infrared, you are gonna trigger interrupt here. Once you trigger interrupt, I'm gonna increment a count. Is that okay, guys? Okay. So you should understand this count, it cannot be a memory. This is a serious mistake. If you want to count some events, it cannot be a register. It has to be a memory location. It cannot be a register because, as I explained before, if you put here a register, the register are going to take the initial values back, as I said, automatically. You got what I'm saying? So you're not going to have counting. So because once you have interrupt, all the register are going to get the initial values back. So that's why it has to be a memory location. Let me show you the video first before I proceed. Look here, guys. Every time I press the button, I make IRQ interrupt. Every time I make IRQ interrupt, you are going to execute the code to shift the LED as you see here. I just want to test if IRQ is working. It is working, right? And in order to do that, I connected, I'm not sure if it's shown here in the video, in another video, I connected an external wire, and that's what you are going to do in the coming lab. I think it was shown in another video. The wire was shown in another video on this. No, I think it's not shown here. But anyway, let me switch here the wire issue. Anyway, so you need to connect this external wire just to transfer the signal from PH0 to IRQ. Okay. So anyway, now any question, guys? Okay. Now I'm gonna teach how can you do the same thing using C language. Okay. So for C language, guys, you have to do it this way. Number one, tell me how you are going to do something like that in C language. How can you do something like that? How can you the interrupt vector, how can you do that in C language? Actually, we're going to do it like in high level, okay, or much easier way. Look how can we do it in C language. This is in C language. This is the main program as usual, guys, and then this is the main function, sorry, and this is the interrupt subroutine. Look what you have to do here, guys. For any interrupt subroutine, you have to use the word void. You have to use the word interrupt. You have to, and then you can put here any name, whatever you name any name, right? But because this is interrupt subroutine for ISR, so I have to put something related to IRQ and ISR. Okay. Yeah. So yeah, don't worry about assignment 5. I'm gonna give you more time to do it because I think I give you the due date what was Thursday. So I'm gonna send you email today to give you one more week. Okay. So anyway, let's continue here. What I'm saying here, guys. So what I'm saying here, guys, is that you have to write the word void for any interrupt. You have to write this one. You can put any name here. However, how I can know this interrupt for IRQ for something else? This magic number here. So if you use number 6, this means IRQ. If for every interrupt, for other interrupts have a different numbers. Look what I'm saying. So for any interrupt source, guys, you have to use this one. You have to use this one. You have to use a number for this interrupt source. How can you get these numbers? I'm going to tell you how can you get these numbers. So if you go to the table, this is actually the number here in the table. So this is number 0. This is number 1, number 2. Number 3, number 4, number 5. This one is number 6. So when you put number 6 here, that means you are telling the C language, this is the interrupt subroutine for IRQ, right? And then C language is going to take care of everything. C language is going to store the beginning address here. Details are hidden. Details are hidden. Okay. Same thing here for RTI. So in case of RTI, I'm going to use number 7. In case of time channel 0, I'm going to use number 8, number 9, and so on. This okay, and then okay, number 2, how can so this is how can you do this part? Okay, but here if I want to compare with C language, how can you do this part here? How you are going to do this? How can you configure if you are going to respond to falling edge or low level? Also for the enable, how can you do that? The way you can do it, guys. Number 1, we have a subroutine. This subroutine is called IRQ_enable. So what this subroutine is gonna do? This subroutine is gonna set IRQ interrupts to low level. So this one is gonna do 2 things. Number 1 is gonna enable the interrupt subroutine, IRQ interrupt subroutines. Number 2, this one is gonna configure interrupts to low level. Okay, you know what? If you go inside, I explained to you before, how can you go inside this function? So if you go inside this function, what you are going to see, you are going to see this instruction here. You are going to see this instruction, guys, but this number is going to be 40. This number is 40. So if you go to inside this function, you will find the same instruction here, but this number is 40, right? I remember. And some students needed to configure it for low level instead of 0 level. In this case, so again, let me say it again, guys. So here we have a function. You can just use this function. But this function is going to enable it for low level. Okay, the question is, what if I want to make it for falling instead of low level? What you can do, okay, instead of writing this instruction, you can try to write something like that. Instead of using function, you can say interrupt control register equals C0. So this one is exactly equivalent to this one here. For some reason in the past, this one didn't work with us. In very rare cases, this one didn't work. So, and what we had to do in this case, you can go inside this function. If you go inside this function, you will see something like that, but this one is 40. So what you can do, you can go inside this function and change this one from 40 to C0. Is that okay, guys? So conclusion, you have here a function. This function is going to enable IRQ interrupts. Also, it's going to configure the IRQ interrupts for low level. If you want to configure, if you want to configure IRQ interrupts for falling edge, you can, instead of using this one, you can use this one. For some reason, if this one doesn't work with you, you can go inside this function and change the number from C0 to from 40 to C0. Okay. So anyway, so that's all what you have to do. Now I'm done. So all what you have to do, you have to use this one, guys, for to enable to configure and enable IRQ interrupts. Also, you have to use this one here for interrupts, as I told you, just number 6 for IRQ. Okay, and then for the code here, as you see here in the code, guys, every time you shift. Every time you shift to port, every time you execute this interrupt subroutine, I'm going to shift to port B, and then if port B is equal to 0, I'm going to make it 1. So these two instructions are exactly similar to the assembly code I used here. Number 1, shift. If it is 0, make it 1. I'm going to talk about this one later. Just forget it for now. Any question, guys? Is that okay? Okay. Now I'm going to move to RTI. You will see I'm going to do exactly the same thing. Explain it right now. The only difference is that this one I'm going to use a different number. Maybe configuration is going to be something different. Also, I have to enable bit. I have to do the enable bit. Also, something I didn't do here, but I have to do it in any other interrupt source. You have to clear the flag bit, right? Same thing here. You have here, I'm gonna, because it's RTI, I'm gonna use here number 7. Okay. So anyway, also I see how can we do configuration here. So, but first of all, tell me what is RTI? What is RTI? I'm gonna tell you what's RTI. But remember, guys, IRQ, in case of IRQ, I have external pin. Every time there is a falling edge, you are gonna trigger interrupt. That's it. Okay. RTI is different. RTI actually is a timer. RTI is a timer. RTI is used if you want to make periodic interrupts. Periodic, for example, every 1 millisecond, something you can configure the time for sure. So for example, if I need interrupts every certain time, for example, every 1 millisecond or every 10 millisecond, whatever, RTI can do that. RTI does not have an external pin. RTI does not have an external pin. It's a timer. So this is something inside the microcontroller. We have here the microprocessor inside it, and then we have a timer. This timer is going to trigger interrupts every fixed time. So in the configuration, I need to configure the timer. I need to configure the timeout. Okay. So this one should give you periodic interrupts. Okay, guys. So again, what's important now is how can you use this one and how can you use RTI? Very simple. You can use RTI if you want to do periodic operations. If you want to do something periodic, every 1 millisecond, you want to do something continuously, something periodic, right? I'm going to use IRQ. Every time there is a falling edge coming from somewhere, I have to take action. Again, this falling edge can come from a fire alarm. It can come from a security system, from anywhere. Okay. So now let me explain RTI. So similar to what I did before. Number 1, how can you initialize the interrupt vector? Okay, go to the table. If I go to the table, I'm gonna see the number I have to use here is a different number. So here, in case of RTI, guys, here a real-time interrupt RTI. So this is the number I have to use, FFF0, right? So that's what I'm gonna do. I'm gonna use FFF0. Yeah, that's what I'm gonna do here. Okay. And then I'm gonna put here the name of the interrupt subroutine. The name of the interrupt subroutine. Okay. Can be any name, but usually this is interrupt subroutine. I have to use ISR. This is RTI usually, but you can put any name. Okay, guys. So I'm gonna use this one instead of using this one here in IRQ. I'm gonna use this one. Very simple, right? So now tell me, I have to tell you, number one, how can you do the configuration? I have to tell you how can you do the enable bit. How can you do the interrupted flag bit? I have to tell you, right? So number one, let's do the configuration. What kind of configuration I can do here? Very simple. The configuration you can do here is a timeout. Timeout means, do you need interrupts every 100 milliseconds, every 2 seconds, every 3 seconds? You have to set the time. You have to set the time. Okay. So how can you do that? Very simple. You have a register. This register is called Rti CTL. This register here, you have to write a number here in this register. That's it. So in order to set the time out, you have to come up with a number and write it to this register, Rti CTL. Okay. What number? It depends on the time. So every time has a different number. So you have to come with a number, just write it to register. Very easy, right? So just write a number to register. So how can I get this number? I'm going to tell you how. Look at the idea. The idea here is that, look here, guys. Here, in this register from 0 to 3, 0 to 3, this part, these 4 bits, I'm going to call them N. And these 3 bits, I'm going to call them M. So we have N and M. N can take a value from 0 to 15. M can take a value from 0 to 7. Is that okay? So anyway, so these 4 bits N, these 4 bits are M, right? And the formula is the timeout should equal N plus 1. This is N and this is M. N plus 1 times 2 to the power M plus 9 divided by 8. So based on the timeout you need, you have to see what is the value of N, what is the value of M, and put it here. But that's too complicated. So that's too complicated. So this is the relation between the value of N, the value of M you write here in this register. Okay. In order to make it simple, I created this table here. As you see here in this table, here N, I put all the values I put here all the values for N, starting from 0, 0, 0 until 1, 1, 1, 1. Okay. Here I put all the values for M, starting from 3 zeros until 3, 1. So here I put all the possible cases here. Okay. And then what I'm putting here in the table, what you can see here in the table is actually this part of the equation. So you have to divide it by 8, and then the result should be in microsecond. So you have to divide this one by 8, and the result should be in microsecond. By the way, in chapter 5, I'm going to explain a more flexible way to set the time. So I'm going to, in chapter 5, I'm going to explain a timer system. This timer system, in my opinion, much better than this one. It's more, there is much more flexibility to set the time. But this one also still okay. But anyway, so this all the possible values you have. So any number here in the table, guys, you have to divide it by 8, and the result should be in microsecond. So for example, I'm gonna pick up some numbers here. If I take this number here, okay, this is the smallest number you can get. So here that means you are gonna get interrupt every 0.128 millisecond. This is the timeout. If I can get this one, and this is the highest time, this is the longest time I can get. If you select this one here, and this one is corresponding to 11111111. It's the highest number I can get. So you can put here 11111111, which is actually 7F. So if I write 7F to register ITCTL, so I'm gonna get this one. And this one actually is corresponding to 131 milliseconds. Is that okay? So the smallest time this timer can give me, is this one. When I put this value for M and this values for N, okay, and so that means you have to put here 0, 0, 0, 0, 4 zeros, right? Look here, 4 zeros, and then 1, 0, 0. 1, 0, 0. Okay, so this number should be actually 10, number 10. So if you, hexadecimal. So if you use 10 hexadecimal, this is the time out, and you have all the numbers here. This one I just pick up a number in the middle. This one can give you 10 milliseconds. Okay, guys. So this is the way you have to do it. I know it is. It's not flexible, but as I said, the chapter 5 in a timer system, that's much more flexible than what I have. So conclusion. In order to configure the timeout, all what you have to do, guys, from this table, you have to see what value based on the time you select. That's why I think most of the time we are going to focus on this. This 3 times should be enough. Okay. So for example, if I want to take this time, guys, all what you have to see, what is the value of M, what is the value of N, and you have to put N. N is here, guys. Remember, N is here, and M is here. And you have to write it in this register. That's it. Okay. Same thing for this one. Same thing for this one. So here M is 100, and this one is 1001. Here, this one, this is M, and this is M. Okay, guys. So for example, if I wanna trigger interrupts every 130, and this is a maximum time. So if you look at for this timer, simple timer, this is the maximum time I can time out, and this is a minimum timeout. Okay, so all the other values here is something between these two. So all what you have to do, guys, for example, if I want to trigger interrupts every 131 milliseconds, I'm gonna write this number or any other number. If you want a different number, just write it in this register. That's it. Do this in the main program. Is that okay? Any questions? Okay, great. Number 2, I have to tell you where is the enable bit, enable local bit. Okay, it was just by accident in IRQ, the configuration bit, and they were in the same register just by accident, right here. Yeah, so both of them were in the same register here, but here no, they are in different registers. So where is the enable bit? So actually the enable bit, this one here in a register, we call it CRIGINT, right? So here, this bit is the enable bit. So what you have to do here, if you want to enable interrupts, you have to write 1 here. If you want to disable interrupts, you just put 0 here. That's it. Look here, guys. So you have to write something like that in the main program. You have to say bit set CRGINT ET. So you have to write here 1 in order to enable RTI interrupts. If you want to disable RTI interrupts, it's the same command I can use, but instead of using bit set, I can use bit clear. Okay, guys, that's very simple. So you have in the main program, you have to write this one. Also, you have to write this one. That's perfect. What else missing here? Only one thing is missing: the enable bit. The interrupt flag bit. Tell me where is the interrupt flag bit? The interrupt flag bit, again, that's what you have to write in the interrupt subroutine. You have to clear it. I didn't do that in IRQ because IRQ is the only exception, but you have to do it for all other. So where is this one? Simply, this one is in this register, CRGFLG. Okay, just in this register. So if all what you have to do, guys, in order to clear the interrupt flag bit, you have to write this command here. You have to write this command. You have to write, once you write 1 here, once you write 1, so the command is going to clear it. Okay, this is how it works. So once you write 1, to this one, this command is going to clear this one, and that's what you have to do. Okay, so let me tell you the conclusion. The conclusion is, guys, number 1, you have to do this one. Okay, number 2, in the main program, you have to write something like this one. For sure, you may change the time, right? This is to set the time out. Number 3, you have to do this one. That's it. In the interrupt subroutine, I have to write this one in the interrupt subroutine. Is that okay, guys? Any questions? Okay. Now what I want to do right now, I want to make a flashing LED. So similar to the program I did in chapter, similar to the program I did in chapter 3. Okay, flashing LED. So I want to turn the LED on for 1 second. I'm going to turn it off for 1 second. However, this time is going to be much, but this time what I did in chapter, by the way, many programs I did in chapter 3, I'm going to repeat them in chapter 4. But the main difference is that in chapter 3, I did the programs, I put them in the main program. Now I'm going to put the same programs or the same tasks, I'm going to put them in the interrupt subroutine. Okay, so that's what I'm going to do now. So what I'm going to do right now, guys, similar to the program I did in chapter 3 to do like a flashing LED, I want to do flashing LED, but using Rti. So Rti is going to do the flashing. Is that okay? How can you do that? That's very simple. Okay, so the idea I'm going to do, guys, is if, for example, if I can do something like that, and you will see by yourself, I want you to compare the program I'm going to do right now with the program. This is the first program I did in chapter 3, flashing LED, right? I want you to compare, and you will understand better how interrupts make things easier, much easier. Okay, and that's not because we are doing magic. No, it's not magic. It's mainly because the difficult part is I don't need to count for 1 second because this is done by the timer, by the hardware. You got what I'm saying? This is the reason we're not doing magic. But if you go to chapter 3, you will see I have to call a subroutine to make a delay, right? That's why it took too much time. However, this task can be done by the timer, by the hardware, right? So anyway, so if I can do something like that, if I can get interrupts every 1 second, here, this is Rti interrupt, and all what I'm gonna say here, I'm gonna say flip LED. That's it. Very simple. So here this is the Rti interrupt subroutine. So inside the Rti interrupt subroutine, if you can make interrupts every 1 second, guys, so that means every 1 second I'm gonna flip the LED. That's it. Very simple. You understand how I can do it? However, there is a problem here. What is the problem here? The problem here is I can't make the timeout cannot be 1 second. Right? If you go to the table, I told you the maximum time you can get 131. This is the maximum. 1 second is a very long time for microcontrollers. Very long time. Is that okay? So the maximum is only 131. So what can I do in this case? Okay, very simple. It's not a big deal. What I'm gonna do, guys, is look, 131 millisecond. Okay, that's I can't do anything about it. This is the maximum I can get. What I can do is every 1 second should have actually 8 interrupts. So 8 times 131 milliseconds should equal around 1 second. So what's going to happen is that I'm going to have interrupt every 131 milliseconds. But actually, I'm not going to flip the LEDs until every 8 interrupts. So I have to count for 8. You got what I'm saying? So for example, look here, guys. So here, this is interrupt 1. So here I'm going to say increment count. Are you 8? No, I'm not 8. Okay, leave. Don't do anything. Okay, so this is interrupt number 1. Interrupt number 2. Increment count. Are you 8? No, I'm not 8. So please don't flip. And so on. So every 8 interrupts, at interrupt number 8, so every 8 interrupts, I'm going to flip the LED because 8 interrupts means 1 second because I'm making interrupt every 131 milliseconds. So 8 interrupts means 1 second. Using the same logic, 16 interrupts means 2 seconds. Using the same logic, 4 interrupts means half a second, and so on. Okay, guys? So all what I'm going to do, I'm going to count. This interrupt 1, interrupt 2, interrupt 3, and then I'm not going to take action unless at interrupt number 8. And then once I'm 8, I have to take action, and then I have to clear the count. I have to clear the count to count for another 8 because it's continuous. Yes, you have a question right there?
Please don't say it again. Usually we don't do for loops and interrupt this. That's what I say. Why not? Because interrupt is coming from external source. It's not something you have to repeat for loops. You got what I'm saying? You should not be confused. So I don't know why you want to use for loops here. No, but I know, I think I know what's confusing you. You are thinking, I'm gonna like make a delay for 131. So I need to get for loop 8 times. That's what you mean, I guess. So I guess what you wanna say, you wanna make full loops 8 times. Because every iteration is gonna take 131. Is that right? No, because if you do this way, the CPU is not gonna be free. Who's gonna count for? I want to CPU to be free to do something else. So if I make a for loop, and in every iteration I have to count for 131, right? I want, very important thing, man. I want the CPU to finish the interrupt subroutine quickly, to go to the main program and to take care of the other interrupt subroutines. I don't want the CPU to be frozen or spend too much time in one task, in one interrupt subroutine. No, just do it quickly and then leave the subroutine quickly, the interrupt subroutine quickly. Why? Because I have other tasks, I have other interrupt subroutines. I have the main program. If I just get one task all the time, it's going to affect the performance of my program. I have other tasks. So what's gonna? I don't know. I don't need for loop here at all. Okay. So what's gonna happen is that I'm gonna show you what I did here. I know many students make the mistake you said right now, but this is very serious because you should understand, guys. Very important, guys. In order to make a big progress, I have to run multiple tests at the same time, right? One test is going to be the main program. One test should be by each interrupt source you have. Okay, so I should have many tests, and you have to write the program in a very good way. Okay, that means every interrupt subroutine should not take much time. I saw some students that test inside the interrupt subroutine, they call delay YMS. So if you do that, if you want to do the delay by yourself, so why you need external timer? If you want the CPU to count for 1 second, right? You understand what I'm saying? CPU is not gonna count for 1 second because I have external timer. It's gonna do that. So I'm not gonna benefit from the subroutine if I call delay YMS inside the interrupt subroutine, right? The main idea, guys, every interrupt subroutine I have to execute it quickly, so that I have to take care of other tasks. If I spend too much time in one subroutine, it's gonna impact the performance of the whole system, right? Okay, so let me show you what I did, and if you have any further question, I'm very happy to answer this kind of questions because I want you to fully understand. Again, I think the best way I can answer it is the main idea of interrupt is I want to free up, I want to free the CPU, right? How? By the hardware is going to do some tasks so that the CPU can be free. The CPU does not need to count for 1 second as we did in chapter 3. The hardware will do that. Who's going to count for 1 second? Okay. For sure, here just we can't make 1 second. That's why you are going to make 131. But that's okay. So who's going to count for 131? Is the hardware, the external hardware, right? So that I have to execute the subroutine quickly in order to be able to do the other tasks. This is the main idea of interrupts. I want to freeze the CPU to take care of other tasks. Okay. Anyway, so number one, this is how I'm going to do the program, guys. As you see here, in order for the interrupt vector. So I have to write this one here. Always you have to use this number for Rti. This is the name of the subroutine. Write any name you want. Okay. But you have to do this one. Okay. This number one. Number two, here, because for sure this is just a configuration. This is just a configuration. You have to
you have to use port B, port P, and so on. This is just a configuration because I'm using one LED. And then you have to write this one. All of that is still in the main program in order to set up the RTI to 131 millisecond. So here this command should configure or set up the timeout to 131 millisecond. This one here, guys, I have to enable interrupts. So this one just enable interrupts, the RTI interrupts, not all interrupts, RTI interrupts. Okay, guys, and this one here enable all interrupts. Once you do that, now RTI is working. So once I do this one, I do this one. Now RTI is working. You already configured RTI, so you're gonna have interrupts every 131 millisecond. Okay, guys, look here, guys. If you wanna enable, you have to use bit set. If you wanna disable RTI interrupts, you have to use here bit clear. Okay. Anyway, and then again, because this is just a very simple program, I have only one task. That's why the main program is free. That's why I'm gonna just make infinite loop here. Why you make infinite loop here? Because if I don't put this part, it's gonna go all the way. It's gonna execute this one, because this is the main program. I told you before, any main program usually are gonna jump to the beginning, so in like loop, or at the very end, I'm gonna keep looping here. But again, the idea here, guys, because this is just a simple program, I can remove this one part here, and I can write a task here. You can do a task, okay? But here, just a simple program. So all the time, I'm gonna keep looping here. Every time this RTI interrupt, I'm gonna go execute the RTI and come back. Go execute and come back. Is that okay? Let's see what I'm gonna write here in the Rti interrupt subroutine. Look here, guys. First, you have to end it with RTI, this number one. Number two, you have to write this one. You have to clear the flag bit. Please don't forget to do this one. Copy paste. Every time you use RTI, you have to put this one in the interrupt subroutine to clear the flag bit. If you forget to write this one, you are gonna have infinite interrupts coming from RTI. Your program is gonna be frozen. It's not gonna work because it's gonna be tight all the time. So CPU is not gonna take care of any other tasks, right? So please don't forget to do this. And as I told you before, all what I'm gonna do, guys, I'm gonna increment a counter. I have a counter here. I'm gonna increment a counter, and then I'm gonna compare the counter to 8. Why 8? Because I wanna take action. I wanna take action every 8 interrupts, every second. Second means 8 interrupts. So I'm gonna compare it to 8. If it is not equal to 8, just leave. Come here and leave. That's it. So every time, if it is equal to 8, I'm gonna come here. Number one, I have to clear the counter. I have to clear the counter so that I can count for another 8, right? And then I'm gonna flip the LED, as you see it. Flip the LED. So this part is gonna be executed every 8 interrupts. Every 8 interrupts means every 1 second. Right? So if I ask you, and that's what we're going to do in the lab, if I ask you to modify this program to do the flashing every half a second, all what you have to do, guys, instead of writing here 8, I'm going to write 4. That's it. So every 4 interrupts, you are going to flip the LED. That's it. If you want to make it every quarter, so I'm going to make it this one 2. Right? If I want to make it every 2 seconds, I'm going to make this one 16. That's it. Okay, guys? Very important thing here, this count, the count you have to use, it has to be a memory location. It cannot be a register, because if you increment a register, as I explained before, automatically all the registers are going to get the initial value. So if you start from 0, increment 0, increment 0, increment 0, because all of them are going to get initial values. That's automatically. I have no control on that. So that's why it has to be a memory location. Okay, this is one thing you should understand. The other thing, you guys, so if I do that, you are going to see flashing. Who is doing the flashing? Who is doing the flashing? The RTI. So RTI is doing flashing. Is that okay? Please, I ask you, when you study this part, I already explained how can you do flashing in chapter 3 in the main program. Compare this one to this one in order to understand, right? In the main program, the microcontroller was busy 100% of the time. Look at the beauty here. The beauty is I'm gonna take very little time from the CPU. Every 131 milliseconds, I'm gonna come here, execute this subroutine, okay, which takes micro nanoseconds, something like that. So okay, so it's not gonna be similar to what I did in chapter 3. Okay. Also very important, because also that's what we are gonna do in the coming lab, guys. Very important here. Who is doing flashing? RTI. As long as RTI is enabled, you are gonna see flashing. Is that okay? If I, for some reason, if I wanna stop the flashing, what I can do, very simple. I'm gonna say disable RTI. So if I disable RTI interrupts, so that means this interrupt subroutine is not gonna be called anymore. That means there is no flashing. In general, for any, again, for every interrupt source, is doing a test. If you wanna suspend this test, so you have to disable the interrupts. Right? So here again, guys. So if you wanna stop the flashing, all what you have to do here, guys, is just you have to disable the interrupt subroutines. Is that okay? And that's what we're gonna do in the coming lab. So let's see the coming lab and also the coming program. But before I continue, so how can you do the same program, the flashing LED right now? How I can do using C language? Okay, very easy. Look here. Number one, this is similar to what I did before. You have to use the word void. You have to use the word interrupt. And now number 7, because 7 for RTI, 6 was for IRQ. When I program the timer, it will be the same thing. I'm going to use a different number, 13, 8, whatever. That's it. And then here you have to put the name. You can put any name. Okay, but for sure, the name has to tell this one for RTI. Okay, guys, this is number 1. So this is the interrupt subroutine. Okay. Okay. Also, how can you configure it? Very simple. All what you have to do, configure it, you guys. I can just use a function here. This function is called Rti Initialization. Okay. This function is going to do all the initialization. So this function is going to enable. So I want you, if you want to learn more, please open this function and see what is the assembly written inside this function. You will find the assembly written inside this function. You find something like this one is written, but for sure different number, as I'm going to explain right now. Also, you will find this one also is written to enable. So inside this function, these 2 instructions are written, right? So inside this function, that's it. So this function should initialize RTI. This one should enable, but this one should set the time automatically to 10.24 milliseconds. So so this function should set the time to 10.24 milliseconds. Okay. So now, what if you want to change this number? Simple. If you want to change this number, so after, because this function has to do 2 things. It's gonna do enable RTI, and then after enable, this function should store 36 in RTI CTL in order to configure it 10 milliseconds. So you need this function to enable RTI. After this function, you can write this one here after the function. You can say RTI CTL equals 7F, because 7F is going to make it 131 milliseconds. What I'm saying, guys, this function should set the time to 10 milliseconds. I'm saying if you want to change the time, you can do one of 2 things. Number 1, you can, after this function, you can write RTCTL equal whatever, anytime you want. This time, 7F is going to make 131 milliseconds. Is that okay? You can do this way. Okay. Or you can go inside this function. Inside this function, you will find this one and this one. You can just change this number with any number you want. Okay. Anyway, so that's all. Very simple. That's all what I need. So all what I need, guys, for to program the RTI interrupts in C language. This is number 1 in the main program, and this is the interrupt subroutine number 2. Also, don't forget to clear the RTI. In order to clear the flag bit, here you can use a register here, clear RTI flag. Okay, you can use you can use a function here. So this function, if you go inside this function, you will find this one is written here inside this function. Okay. So now what I'm gonna do now is so here I want to make interrupt. I want to make interrupts if I want to flip LED every 1 second. So every 1 second, it means in 1 second how many 10.24 millisecond we have in 1 second? Actually 97. So every 97 interrupts, it means 1 second, because we have one interrupt every 10.24. Okay, guys. Please, very important thing, guys. Please, still, if some students, I see some students are confused about the concept of interrupt. Okay, some students, I saw some students in the past, guys, inside the interrupt subroutine here, they make a delay for YMS because they don't realize, they don't understand, they don't understand that they think they have to make the delay using the software. If you have to make the delay using software, you don't have a beauty here. You don't have the beauty of interrupt. The beauty of interrupt is that the delay is going to be by the external time. So you don't need to do this one. Okay. So anyway, as you see here, guys, here I'm going to have a variable. I'm going to call it tick. Okay, whatever the name is, I'm going to call. So this one should count interrupt 1, interrupt 2, interrupt 3, and so on. This variable, I know some of you may not be too strong in C language. This variable has to be global this way. If I define this variable inside here, so once I finish the function, it's going to be deleted from memory, right? Because this variable should count interrupt 1, interrupt 2, interrupt 3, interrupt 4. So it has to be global. If you define inside here, it's not going to work. Okay, because if you define here, once you come here, it's going to be deleted from memory. It's not going to memorize the value. So that's why this one has to be global. Every interrupt, I'm going to increment this one. And then I'm going to check, are you 97? No, just leave. 97? No. Every 97, so I'm going to actually flip the LED, and then I'm going to clear it to count for another 97. That's exactly the same thing I did here. Here I have to count for ITI every 8 interrupts. I have to clear, but here it's 8 interrupts because you can make this one 8 interrupts. That's okay. You can make it interrupts. If you want to make it 8 interrupts, the time. So here you have to make sure the time is 131 milliseconds, right? I'm just teaching in different ways, but I'm not saying it has to be this way. Just different ways. Okay. So if you make the delay 10 milliseconds, 10.24 milliseconds. So here it has to be not 97. Okay, guys. So every 97 interrupts means 1 second. That's it. So every 10 millisecond, microcontroller is gonna come here fast and leave. Come fast and leave. How much time this will take? Nothing. And that's exactly. Keep in mind. Look here, guys. This is like a golden rule. If you write too much code inside the subroutine, inside the interrupt subroutine, you should feel something is wrong. You should feel something is wrong because it's not supposed to be this, something like that. It has to be quick, right? So anyway, so something is wrong. Or you maybe you are programming in an efficient way, right? But anyway, any question here, guys? Very simple. Any questions? Okay. Now I'm gonna teach a program. So now, let me tell you what I did. I explained how can you program IRQ, how can you program RTI. Now I'm gonna make a program, and then I'm gonna use both of them. How? And that's what we're gonna do in the coming lab. So the coming lab is just a little bit modification to this one. So here, what I'm gonna do here, guys, is that I'm gonna use IRQ. I'm gonna use RTI. I'm gonna use RTI to make a flashing LED every 1 second, similar to what I did right now. Okay, so RTI is gonna be used for flashing LED. On top of that, I'm gonna use RTI to enable or disable RTI interrupts. So RTI is connected to push button, so that when I press the push button,
Rti interrupts are disabled, no flashing. When I press the button again, Rti interrupts are enabled. You can see flashing and so on.
Okay. So I think let me show the video flashing. Look here, guys. I press the button, no flashing. Why? Because I disable in IRQ, I disable Rti interrupts. Okay, so let me press again. I enable Rti. Flashing is working. So this is why I told you when I did this video, I was at home. I didn't have a nice wire, so that's what I found in my home. So I did that's the external wire I told you about. I connected here. It's not very nice wire, but it worked. So anyway, so I'm gonna show you here how I made it. Okay. So here I'm gonna use the same program I just explained right now for Rti to make a flashing every 1 second. However, in IRQ, the secret here in IRQ, look what I did in IRQ. In IRQ, guys, every time you trigger IRQ interrupt, look what I'm going to do. I'm going to read CRGINT, then I'm going to XOR the last bit of this register, the last bit of this register. Remember, this register, the last bit is the enable or disable for Rti. Let me go back to Rti if you don't believe me. Let go Rti. Yeah, look here, guys. This is for, yeah, this one, this register. So what I'm gonna do, guys, I'm gonna read here. I'm gonna flip this bit. In IRQ, I'm gonna flip this bit. When you flip this bit, that means if it is enabled, I'm gonna hit disable, and then enable, disable. So every time I trigger IRQ interrupt, it is enabled, I'm gonna make it disable. Disable, you make it enable. Is that okay? How you made it? Just yeah, as you see here in IRQ. Okay, so let me quickly go through it. Nothing is new. Just give me 1 second. Nothing is new. I just want to show you how I'm going to use both of them. As you see here, guys, I have to use this org for Rti. I have to use this org for IRQ. So I have two now. If you have more interrupts, you have to add more. That's okay. Also, you have to use these two for Rti, as I explained. You have to use this one for IRQ. That's okay. Rti, this is similar to what I explained right now. Okay, so this is the main program I'm here. If there is interrupt from IRQ, I'm gonna Rti, I'm gonna go to Rti and come back. If there is interrupt from IRQ, I'm gonna go to IRQ and come back, and so on. And this is so Rti, this is similar to what I explained right now. For IRQ, this is just the part I added here. So every time I press the button, I'm gonna make IRQ interrupt. IRQ is gonna flip this bit so that Rti is enabled. You see flashing. Disabled, no flashing, right? Okay, how can you do it in C language? Is exactly the same thing, guys. As you see here, we have two. I'm gonna make two. Number 7. This is for Rti, and this is exactly the same thing I explained right now. Okay, this is just for flashing. Here for IRQ, number 6. And the way I'm going to do it right now, maybe I'm going to do it in a different way. This is similar to what I did in the last, what you did in the last lab. You remember in the last lab, if the cursor on line 1, move it to line 2. Line 2, move it to line 1. How you did it? Using a variable. It's the same thing right now. Same idea. So now I'm going to use a variable. This variable, I'm going to call it status. So status should take one of two values, 0 or 1. One value, it means it is enabled, so I have to disable. One for disabled, so it's enabled, right? Here I'm talking about Rti. So as you see here, guys, I'm going to say, if status is equal 0, that means Rti is disabled. So now I have to enable. So in order to enable Rti, we have a function, Rti enable. And now I make status is 1. When you press again, if status is equal to 1, I'm going to make it 0, and then I'm going to disable. You see what I did? So now
I'm going to use a variable to tell me if RTI is enabled or disabled. Enable, I'm going to make it disabled. Disabled, I'm going to make it enabled. Right? Again, this is just a different idea. You can use XOR as I did here. So you can use something like XOR. You can do it this way, but this is just a different idea. Okay, guys? So every time, so actually one interrupt here, the second interrupt here. So one interrupt here, the second one here, and then one interrupt here, the second is here. So we are alternating between these two, right? Because if it is disabled 0, so I'm gonna enable it and then I'm gonna put 1. Next time it is enabled, so I'm gonna come here to put 0 and disable it, right? And finally, that's it. If you look at the main program, I have to write this one to enable IRQ interrupt, this one for RTI. That's it. So now I explain how can use both of them. Okay, guys. So again, what I did today, I explained IRQ, one program for IRQ, I explained one program for RTI, and then I explained how can you put the two programs together, or how can you use, sorry, not the two programs, how can you use both of them together, RTI and IRQ, right? RTI is doing flashing, IRQ should control RTI, enable or disable. So that when I press the button, if it is enabled, we make it disabled. Okay, disable, you make it enable, and so on. Okay, guys. Any questions? Let me tell you something quickly because you're still confused about the idea of interrupts. For example, just an example. I'm gonna use RTI to do police alarm. You can do something like that. Okay, police alarm. If there is a fire, okay, and you wanna turn the alarm on, how can you do that? Very simple. Enable RTI interrupts. You can hear alarm, right? There is no dangerous now, and you wanna turn the alarm off. Disable RTI interrupts. That's it. Similar to what I did here. What I did here, we have flashing. RTI is doing flashing, and then you can turn it. If you want to do flashing, turn RTI on. If not, turn RTI off. Same thing. And instead of flashing, I can put here the police alarm, as we explained. You can do that. I think I did it in one part. So that if you want to energize the alarm, enable RTI. If you want to turn it off, disable RTI. Okay, guys. Any questions? Oh, I exceeded the time. Sorry, I had to finish this part.